All right. Hey guys, welcome to the first episode of Behind the Tech with Thea. And today I have my co-host, Ben Shuri, who is the expert, I would say, in AI, in deep tech. He's been here working. So you started your career in the US and then you've been here for the past,
since 2006, so almost 20 years.
Almost 20 years.
Yeah.
And he has worked on so many different projects throughout Southeast Asia and in Thailand. And I'm so glad to have you. And maybe before we start off the podcast, you explain a little bit about who you are, what's your career path been, and what are you working on now?
All right. Yeah. So that's not gonna be short because I'm old. So I've been around
for the TLDR version.
I'll try to. Yeah. So when I was a uber geek programmer, right? Didn't know anything about business. And when I was 20 years old, I accidentally started my own company because my boss blew his company in Vegas one weekend. So that's a story in and of itself. And unfortunately, I was in a little town called Fort Smith, Arkansas, and I had clients, and I didn't know things about having to pay quarterly taxes, and so I would have to ask them to pay me in advance, because I didn't cover that. And they took care of me because I also knew that I was the only geek in town. We were one trick pony in Fort Smith. And then from there, I started doing contracting work, first in Dallas and then around the rest of the U.S. and some occasionally in Europe and the UK. Cleaning up a lot of big projects is really what I got hired ostensibly because of my technical skills. I was a C++ guy. I was early recruited to be one of the original quants, but I didn't want to live in New York City. Mm-hmm. So did that for a long time. Found that a lot of the best technical people that I had hired for my clients were Asian-born Asians. Mm-hmm. And around 2000, started thinking, they kind of outnumber us, and there's obviously a lot of potential, but there is not a single example of a world-class, innovative, disruptive software development group in Asia. It just doesn't exist. And talking about from India all the way to Japan and everything in between. And I came up to the theory that it's because there really was no technical career paths here. So you get these really bright kids with great potential, come out of the university, they go work for some multinational firm. They would program in whatever was the language that firm had. So in 2000, that meant you were a C# programmer or a Java programmer. And you'd write code for 2, maybe 5 years. And then your salary is, that's as far as you can go. And then they promote you to manager. You'd manage 20 other people. You never write another line of code again. And of course, the worst thing you can do to a geek is to make them manage other people. So that's why Asia has not had success in innovation. So I said, all right, I want to come to Asia and build a world-class development group. And I want to give them the titles and salaries they would get if they got up to the management. But I'm going to introduce them to a lot of different technologies and a lot of different work domains. Yeah. And so I created, so Reuters asked me to build them a team here, and because they were consolidating some of their divisions. And so I came here in 2006 for them, and they had 13 people doing 2 projects. And I told them it was going to take me 2 years to do what they wanted, and if I liked what I found, I would start my own company here. So I came here in 2006, and they had the 13 people doing 2 projects. In 18 months, I turned that to 90 people doing 10 projects. We were, I think, we were certainly the most innovative group inside there. We were really pushing the boundaries. They were a big C++ and C#.NET Windows company, and I brought in Postgres and Python and Linux into Reuters for the first time. And so I said, okay, I like this. And in 2008, I started Proteus Technologies in my spare bedroom in Bangkok and grew that to 36-ish people. I never wanted to get above 40 people because then you have to have HR staff. Yeah. I don't want HR staff. And sold that company in 2018, worked for that group for 2 years that bought us, then started a new company. And that has evolved to become Biggest Lab. Mm-hmm. And we did a lot of stuff in crypto innovation. We've actually made changes to the core protocol for Bitcoin Cash, done some interesting things on the Ethereum space, and also do a lot of enterprise systems. So when like things that people have heard of. When Alibaba bought Lazada, they hired us to glue their back-end systems together, that kind of stuff. So we were big in the logistics space, and now we're doing a lot of, we're pushing the envelope on the AI space, I think. So that's kind of what I think is the subject you want to talk about today.
Yeah, that's what we want to, because the thing about Ben is, guys, because you say you're old, right? That's not me putting that on you. You've worked on so many areas within tech, and not only are you a technical person, you understand the people side as well. Because I see the way you manage, I see the way you talk to people, and out of all the technical devs that I've ever met, you're the only one who can actually explain things to me in a way that, you know what, I come out of the conversation thinking, you know, I think I got that. I understand what he actually said to me, because you guys don't understand. There's so many different people who would assume that you know this, assume that you know that when you talk about a topic. So that's why we have Ben here today, and we're going to be doing these podcasts talking about everything from like technical news and different areas within AI, because I think that's currently something that you are working on, something that a lot of people are interested in. So we can definitely explain that in a more concise and easy way. So today, I sent Ben a little bit of news. There's this one big news that we want to talk about first. Actually, it's an extension of a few news. So within the AI space right now, there's this word that is so hot: artificial super intelligence. And recently, Meta did this mass hiring where they went on and hired like the most advanced, I would say, people within this space, like 11 of the best people. They even acquired a new company, they acquired Scale AI, and got their CEO, Alexander Wang, to now lead the artificial superintelligence group. What is your take on the pursuit of artificial superintelligence?
Okay, well, so I'll admit to a bias here. I am naturally a contrarian.
Okay.
So I call bullshit on it, and that's what it is. This is not an AI play. This is a VC play. This is people, so there's two things going on in the AI space. One is there's some people who are actually trying to do innovation in there. And we've been through 3 cycles of this. Like in the 60s and 70s, everyone thought that Lisp was going to bring us AI. I mean, the top people thought...
What is Lisp?
Lisp is a programming language that it's a more of a functional style programming language that just everything works on lists, and it more represented some levels of abstraction about human reasoning than programming language of the day like Fortran and COBOL, which were just computations. Okay. So there was a company called Thinking Machine Corporation that actually built a machine that tried to, like, the physical components were like closer to the language to reduce the impedance mismatch between the language and the implementation, which is a good idea. And they were, there was lots of money put into the AI space in the 60s and 70s, and everyone thought that we were just, 5 years or 10 years away from computers that could think, and that programmers were going to be obsolete. All right. And then that turned into zero. That was, I mean, it improved the computer science space, right, and some things that we were capable of doing, and learning about programming from higher level human abstractions rather than how a machine can work. Yeah. Basically because machines got more capability and you weren't having to code to the machine. You could start coding to the thought process of what you're trying to do. So we were humanizing computing. But there was like no chance. So what happened then? What was the mistake, right? Everyone always over-exaggerates what the technology can actually do, mostly to get funding or raise money. And everyone underestimates what it means to be a human. Yeah. And what intelligence is, and they can't even define it. Yeah. And the definitions that they have, I find incredibly lacking. Like the Turing test is a good which is what everyone uses, right? Which most people use, is a good, heuristic to say, hey, we're doing something that resembles or simulates how a human talks and thinks. But it is not the equivalent. And I have a model which we could discuss later because of my general systems thinking background that I think is closer. It's also inadequate, but it is a better model. What was his name? Conway? No, not Conway. Box. Who's a statistician during World War II. He has a saying that all models are wrong, but some are useful. Right? So every abstraction that humans come up with how to describe the thing has got fundamental mistakes in it. But if you capture enough of the stuff that deals with the context you're dealing with, these models let you really do things and let you improve society and deliver value. And that's all that AI is. It's not creating intelligence. So when you put superlatives like super intelligence in front of it, you haven't even done the intelligence part yet. And the super nonsense is like, what? Because it can remember lots of stuff because it's a computer? I don't. What's super about it?
Because here's the thing, right?
What's super about it is the valuation you're getting. That's what's super.
What I've been hearing, like you are spot on in saying that we underestimate what is a human, right? Because I've always been questioning this part. Like, we don't even understand what intelligence comes from, what is consciousness, how do we apply that to an AI? Because what they're saying, so right now the separate AI, AGI, and ASI is that AI is where we are now, the predictive kind of LLMs. AGI will be the next level of like, oh, it can think by itself, it can do more than one thing. And the ASI that they're trying to push right now is that it will be smarter than any human. It has its mind of its own, ability to think, ability to have intelligence, ability to create its own conscious
singularity.
thoughts. Singularity, like that. So which
I thought had something to do with black holes, but okay.
But yeah, so your take is that we are still far off because we still underestimate the power of human and what humans are in order to recreate human.
Right. So models are like maps, right? So there's a famous saying, the map is not the terrain, right? But to use that analogy, if you have a map and you're trying to figure out where you are and where you're going, you got to be able to define the spots on the map so you can plot the route.
Okay.
No one can define intelligence, so nobody can say where is intelligence, right? How do we know that we've achieved this, right? Because people, like the nihilistic transhumanists, who claim to be scientists but they really practice scientism, just think everything is fully deterministic and just came together randomly, but this is the way things are going to be, and there is nothing beyond what our minds are able to comprehend. Yeah. Now I am first and foremost, I believe in the scientific method for addressing scientific questions, and I think just using that alone is adequate to define a useful enough model for intelligence that you can pursue that, and that has real value to society and stuff. To then claim that goes beyond what human intelligence is, you got to get into the realm of philosophy, and you have to go beyond what the scientific method can do. Because the scientific method is all about, hey, there's a lot of complexity in the world. Let's control all these variables and say, for all other things being equal, and just narrow it down so that we're only chasing one or two variables, right? And so that's how you make scientific discoveries. That's what the scientific method is, with the hypothesis theory and law. But that doesn't work in the, that works when you can isolate things in a laboratory, but it doesn't work in the real world. You can't explain the real world. You get this geometric complexity when you add more variables which are in the real world. You get unbounded non-determinism,
what is that?
You can have things that are deterministic, which means they're predictable step by step. Yeah. You can recreate it exactly the same way, and then you also have like computing models. Most computer languages come from this model that's called lambda calculus. Okay. And that's actually that is actually where Lisp really came from and lets you start representing computations using this lambda calculus. It's a very deterministic model, and when you've got a single machine, right, that you control the order of everything that happens to it and everything it sees, deterministic models can work, and that's the way 99% of computer science has worked since we invented it in the 40s and 50s. But then when you have these distributed machines, right, that are around the world, and one machine here gets an event here, one machine gets an event here, and then there's somebody in the middle observing when these events come, you get this non-determined, you don't know, you can't control which event's going to arrive in which order. So this becomes non-deterministic. And we recognized this as our computers got bigger, that we needed to model something better than that. And what is the guy who created the actor model? Oh my God, I'm so bad at proper nouns. Carl Hewitt, in 1977 came up with this concept called the actor model, and he showed that you could not, through lambda calculus, model an unbounded non-deterministic system, which is the way the universe works, which is the way our particles and everything all interact in the universe. And another guy whose name I'm forgetting, and I feel bad about it because he's a genius too. He came up with CSP, which
you can look it up and we can.
Yeah, I'll have to look it up.
Yeah.
We'll edit this in post production for all my forgetting. But he came up with a lambda calculus model that is it's the concurrency model that actually Golang uses. That is still doing lambda calculus, but lets you do some non-determinism, but it's bounded within limits, okay, which is what science requires. But it doesn't allow you to fully represent a model that's the computation of the universe. And so the actor model that Hewitt did in '77 kind of does this. And two of the programming languages we use is Erlang and Elixir, sit on top of this actor model system. So we're able to address that kind of thing. But none of the AIs are looking at things this way. They're all very, very deterministic systems.
So I want to roll it back a little bit to, you said that there were 3 phases. It was like the list, and then what was the second phase?
Right.
What's the third phase? And also, what are you working on then that is exciting to you now within this AI field?
Yeah, so the whole Lisp AI thing was in the late 60s and 70s, and then that went away. And that's when I was becoming a programmer in the early 80s. And then what became all the rage was a thing called expert systems. And expert systems were kind of like defining, is like this logic trail. You have these observations, and by the process of elimination, this must be the next step you take to solve this problem. I worked on a few expert systems in the late 80s and early 90s, and I remember like one for the military that was helping Army maintenance people like figure out what's wrong with this helicopter engine, right? So they have all these gauges and stuff you read, you put in the inputs, you say this is what the behavior, and by doing sort of a differential diagnosis, like what an evidence-based doctor would do, it would say, okay, replace this, do this, and then you would get the engine back up and going. And so it would guide somebody who didn't have to know all the intricate details of how this super complex $1 million engine costs. He could fix it. And so this is creating kind of an ontology of what it means to be this process. It's like a domain-specific language, which is another one of my things. And the problem is it required humans to define these rules, right? So it's a rule set following system.
Okay, so let's go back. What is an ontology? How would you explain it to people who've never heard of what this is before?
Right. So an ontology is it's sort of a diagram defining the relationship of entities. Right. You have a whole bunch of entities and the relationships between them. You might see them as graphs represented in triplets. You have a subject, which is the core subject we're talking about. You have an object, which is what we're going to be related to, and you have this line in between it, which is the predicate, which describes what this relationship is. Like this is this, or this has one of these things, or this processes this object. And so you build this up into a graph, and it's a way of deterministically describing some domain in the world. And one of the things that I like, I'm a computer programming language geek. I like making programming languages because it lets you express things. So one of the things that you noted is that one of the things that I had to sink or swim, because when I was 20, I started my own company and I was this geek guy, I had to figure out how to talk to business people who had never had computers before. I'm in Arkansas. Most of my clients, it was their first time to ever see a computer. And I had to be able to translate back and forth between those. And a good thing to do was to create a special language for their system. So like doing a warehouse management system, the workers know these terms like pick and put, and there's terms about managing a warehouse that is part of the nomenclature of managing a warehouse. And so what I would do is I would create a system that has a domain-specific language that uses the terms that they do. And so it's not a very complicated language, so it can't express, doing advanced mathematics and stuff like this, but it can express all of the processes of managing a warehouse using this ontology, which is basically capturing the processes of the client side. Now, doing that requires domain expertise, requires a lot of knowledge and experience, And the bigger it gets, right, you get this explosion of variables. It gets geometrically complex, and they're very popular in academia. And there's a lot of academics who have tried to create ontologies of things. And if they're precise things like biotech, there's some really good, valuable ontologies out there that I've done really incredible things with. But when they're just trying to describe things that are in the loose human area, they go down this deep rabbit hole and they never get back up because you don't know what's the right level of granularity to describe this, and it just takes too long. So what happened with expert systems is that they simply got too big and no human could manage them, and so they would not scale, right? And so expert systems finally fell out of favor, along with what were the software? Oh my goodness, I'm forgetting the word. There's a whole style of software you build diagrams and then it would create the code for you, those were getting a lot of money from a company called ADW and also Texas Instruments. Was like all the rage in the enterprise.
So when was this, in the 90s?
Yeah, this late 80s and early 90s,
Late 80s,
right? All the way, well, actually all the way through like 94, 95 is when that ran out. And they were all saying, okay, this is going to obsolete programmers. We're not going to need programmers because we just need to define these domains and do this. And so now today, we've got LLMs.
Okay, yeah, so fast forward from then, now the new thing is LLMs.
Yeah.
But don't they hallucinate and they're not still perfect?
Well, I mean, everything's
you're gonna get
perfect.
there.
Yeah, so this is what they did for branding. So like, okay, LLMs are basically neural networks, which again is a model. If you understand how neurons really work in the human brain, like neurons almost never fire, and they're actually not even physically connected to each other for their interaction. And some are connected, some aren't. Like the whole way neurons in your brain work, and the requirement that they're like folded and next to each other, and this approximation about how it is, and the density of them is so different than the way a neural network, a computer neuron, works. But it's an interesting abstraction that allowed us to deal with some fuzzy logic. So it was a useful abstraction, right? George P. Box again. I was doing neural networks in the 90s.
Okay.
I was making trading systems for clients that dealt with fuzzy values and was able to predict things, to identify patterns and say, okay, I'm in this pattern or I'm in this pattern, and then that would allow me to perform an action or a trade that would give me a better chance than somebody who was on a pure deterministic model.
Okay, so wait, let's define for everyone first. An LLM is a large language model that is created based on neural network kind of like design.
It's neural networks all the way down.
Yeah, so what does it actually look like? Because we've all heard of like, you know, ChatGPT, Grok, like all these large language models where they're like chatbots. But what is actually the behind the scenes of an LLM? How does it come together?
Yeah, so the way I first encountered an LLM without knowing it was I was helping my friend Meng Wang's company in Singapore called Legalese.com, and he was trying to solve a problem that he had set up an incubator, kind of like Y Combinator in Singapore, and this was the very first successful startup incubator in Southeast Asia, called JFDI, Joyful Frog Digital Incubator. We had to call it that because the government wouldn't fund Just Fucking Do It, which is what the real name was.
Okay, Joyful Frog.
So Joyful Frog Digital Incubator was the official name registered in the company.
Yeah.
So the model, just like Y Combinator, right? Initially it was like, I think they were given $25,000, but then it upgraded to $50,000. The incubator gets a portion of your equity. You work within the incubator for 100 days, and hopefully at the end, through the advice and experience of going through the incubator, you get funded. And they were very successful. A lot of companies got good funding, and it was, at a time that was very hard to get funding for startups in Southeast Asia. The frustration that Meng had was that in order to give these people $25,000 or $50,000, the legal fees of making the contract document, which was, I think initially was it was a safe document, or it could have been anyway, it was a type of investment structure. Cost $10,000 in legal fees to give them this amount of money, right? That doesn't scale. And so Meng came up with the idea is like, I'd really like to create a domain-specific language that logically describes the contract, like first refusal rights and employment option programs and all that kind of stuff that would be present. Do that as sort of a code language. But then the compiler output would not be a program that does this, but it would be a human readable contract using Singaporean law and written in a manner that a judge and a lawyer would recognize and think, okay, yeah, this is nothing, doesn't look like it's computer generated or whatever, right? So doing the logic of that, putting together the scripting options for that, which is a formalized deterministic system. Law is like code, right? This is software is eating law was what is what their motto was, inspired by Andreessen thing, software eating the world. And the hard thing was, of course, getting the output to look like a human wrote it. And so we were researching these grammar libraries and all this kind of stuff, and we ran into this one service that said they could do this. And we tried it out because they were happy that somebody was going to use this thing, and it was GPT. And I didn't know anything about what an LLM was. I had not been keeping up on the thing. And
what year was this?
This would have been 2018, I think. And so we had some email communications, because I had been doing a lot of stuff with neural networks. I said, okay, this is like so one of the problems with neural networks, one of the reasons why they don't scale, is you have this problem called overtraining or overfitting. And the problem with when you're training a neural network, right? You'll see the answer will get better and better, and then it'll drop off, and it'll get better and better, and it'll drop off. But at some point in time, it'll hit this saturation thing based off of the number of neurons and the number of pathways between it, and then it'll just go, and it'll turn into garbage, right? And it's never going to come back, and you can't predict when that's going to happen. So you have to take a lot of snapshots and just say, okay, this was good enough, and stop there. And so I was, when I learned this was all based off of neural networks, I asked the question like, how are you guys dealing with the overfitting problem, right? That was the ultimate problem that stopped neural network stuff in the 90s. And he says the number of levels of our network is just insanely huge. It is a massive, massive neural network, which meant that somebody took a huge risk of buying a lot of, in this case, GPUs or whatever, and had to spend millions of dollars to train this with a massive amount of data, seeing it get better and worse and better and worse, and not knowing when it was going to hit an overtraining limit, right? So this is a huge risk. I don't know who were the people who first did this. I guess it was the GPT folks that did this. But someone took a huge risk not knowing if a neural network could grow that big, because it's expensive as hell. And you could, it could have just gone to zero, right? It could have been, so it paid off. And he said, like, we haven't hit the overtraining limit yet. I went, wow. And then he goes, wait till you see the next version. And that was my introduction to GPT. Okay. So what? And the output was quite strong, right? People saw, oh wow, this really looks like a human wrote it. So so what does the LLM do? It solves the issue of human-computer interaction. Yeah. This has been one of the most complicated and complex costs of building computer systems that are usable by normal people, right? The first programs in the 50s and 60s, you were flipping switches. You had to know how the computer worked intricately just to be able to ask it a question and to understand its answers, right? You had to know binary, you had to know how logic arrays worked and all that kind of stuff. And then in the 70s, you had mainframes and you had systems where like an accountant could enter in stuff and they would have a screen and a form, something like that, right? And so that was interactive computing. That was the first concept of interactive computing. And what do you figure, like in building this complex accounting system, like a payroll system, and allowing normal people to come in and edit employee records and do it, that not have to be a computer trained person. What do you figure is the percentage of the code base for doing the complex accounting logic and just showing the forms and letting the humans enter in the data who wasn't a computer expert? It was like 20% logic and 80% UI. Yeah. Even for COBOL and all this kind of stuff in the 70s. And then in the 80s, we were doing PCs. I was doing D-based programming. And and building small database applications for my clients. And again, we had some like text-based windowing, right? So this is all DOS stuff. And again, it's like 80% of my effort was the UI code, and 20% was whatever is the business logic that they had. 90s, we had Windows, and Macs were starting to get into the business space, and you had GUIs, right? So, everything is so much easier to use, which you could argue it was easier to use, but it also now 85% of my code base was visual logic, and only 15 was the business logic. Now, this gets into if you're going to make something twice as easy to use, it basically is 10 times more complex to create that, right? So that was like the Apple II to the Macintosh, inspired by Xerox's PARC project, right? To build those systems that Engelbert demonstrated in 1968, the world's best demo. If anyone, you look that up on YouTube. That was 1968. He showed a mouse and folders on a screen with videos. Wow. But the expense of doing that was insane.
Yeah.
Right? So, Windows and the Macs brought windowing environments in there, but it actually made, the human-computer interaction aspect was the majority of the cost. And that's the way it's been, since the 90s. But now you got LLMs, you can literally talk to the things.
Yeah.
And they can appear to understand because they give you the output that you want, and you can have it generate content that looks like it was written and spoken like a human, right? So it's passing the Turing test if you have a decent knowledge base about it. So in that respect, LLMs, and if you want to call it AI, I guess you can, because anything like the LISA program, which is a basic program in the 1970s, appeared to be like a psychologist that you were talking to, right? It was just it exposes not that the system is intelligent. It exposes that what humans do isn't nearly as intelligent as what we think it is, or complex. It exposes that 90% of what humans are talking about and stuff is just setting the context. And there's this guy named Shannon who defined what is the minimum amount of bits required to express some piece of data. So we've got Shannon encoding. So how dense is your Shannon encoding shows that you have an optimized protocol. The Shannon encoding for human speech is really, really poor.
Don't they say that the Singaporean Singlish is the most optimum way because you say the least amount of words to...
Maybe.
Okay. Yeah, okay, so now we kind of are at the 3 phases. Yeah. Right? This is something I feel like most people want to understand. Like you say, there's multiple different iterations of what we've been trying to do, and it's what going to be AI. And right now...
And we made the same expectations, and we're making the same mistakes.
Right now we're LLMs. But is AI, and all that AI is, really just this LLM? There's other parts, right? Because whenever I see these different companies come out and say, oh, this is our new model, this is multimodal, this is our other AI, how do we know if this is an LLM or if this is a new thing? Because I know Palantir also has their own ontology programs. It's a whole different AI thing. So right now we're in this phase where everyone's kind of going LLMs, but there's going to be a cap to it, right? People are going to realize, okay, LLMs are not the only way, and then there's probably other methods as well. Where do you think we're going to go to next?
Yeah, I feel like I'm shouting in a forest and nobody hear it. But I know I'm not the other person who's come to this conclusion, but there's a lot of people with moneyed interests that are still focused almost exclusively on the LLM side of things. And OpenAI is one of them, and all that. But the head of AI at Meta, who's Yakun or something like that, I'm forgetting his name. Good on proper nouns. He said something about 2 years ago, which is it was so amazing to see him say this. He says LLM's got about 5 years, right? And then we're going to hit the limits of what an LLM can actually do, because we will have consumed all the written human knowledge there is and put that into the LLM. That's one of the limitations, right? Just what is going to be in there. And he pointed out that experiential AI is what would be necessary in order to get something that is close. If we want to achieve an actual intelligence, he believes strongly, and I agree, if it can be done, or actually it's going to be the right direction, right? We might be arguing what the destination is, but the direction is this. You need to have experiential AI. And what that is, how do we learn as humans, right? When you're born as a baby, you're tasting things, you're interacting with things, and this is how you learn. But it requires a whole lot of data. You just can't read a bunch of text.
Wait, so experiential AI and LLMs, what is the difference? Because you said LLMs, you just kind of like feed it all this, you build the model, you feed it information, and then it does.
You're feeding LLMs text, right?
Oh, okay.
It's the written world. It's whatever has been written down in human civilization, capture that. It can regurgitate that. Because let's talk about what an LLM is real quick. Okay. An LLM is a very, very basic primitive thing. It is a token predictor. Okay. Imagine if you had a parrot that was immortal, and it's been around for all of human history. It's heard and remembers everything it's ever encountered.
Yeah.
And you say something to it, and so it starts kicking off and saying things that are related to what you said because it's heard something similar in the past.
Yep.
And all it's doing is it's saying, okay, I've got this input string, which it cuts into tokens, phonemes or words or however, whatever the granularity that you cut it into. And then it looks in all this vast, billions of tokens that are in this neural network. And it says, given this set of inputs, what is probabilistically the next most likely token that would belong here? And then it sticks that token on there. And then it takes this new combined thing and just puts it in again. And it just keeps doing that until something tells it to stop because you got some limits in the program or whatever. That's all it's doing. It's just regurgitating things that are likely to have been seen in the past. And so this is the most likely path of tokens. It is not reasoning about the concepts. It can't reason about anything. It's only looking at these set of inputs. Now, when you have a large enough database, when you have just an insane, huge database, it's naturally, accidentally capturing all the patterns of logic and reason that humans have expressed because this is the way humans communicate things. And so it appears that it's thinking because it talks and acts just like a thinking person would, but it's not capable of coming up with a new concept. It's not capable of saying any token that it hasn't seen before. It can't create new tokens, right? And then when you have something so huge, tiny statistical errors will then make a massive influence on which direction the token prediction will get. And then that's called hallucinations, right? I haven't seen anything that statistically fits what you put in here. But this is the next this is the next most, it doesn't know that it hasn't seen anything. It just knows here's the most likely token. And so the next most likely token, which has never been connected with this phrase, is just as good an answer as one that's been connected to this phrase all the time from an LLM.
That's how it hallucinates.
That is hallucination. And so LLMs are pathological liars. Because a pathological liar they'll lie just as well as they'll tell you something was true, right? They'll tell you the sun rises in the west with absolutely every bit as confident as it would telling you the sun rises in the east.
Yeah.
That's an LLM. That's all LLMs are. That's all LLMs will ever be. It's a fantastic statistical probabilistic tool for human-computer interaction. Yeah. And that's it.
Okay. So
the end.
And then it's obvious that this is not going to be the answer to all of our questions. This is not going to take us to AGI, to ASI, or anything like that. So what is... Okay, and then you said that the head of Meta talked about how experiential. So what is that compared to
being based, so like humans don't learn, babies don't learn from reading, right? Everything there is to read, right? They're hearing things, they start understanding patterns and get logic. It's our neurons doing this. So the terms of the model. It's a problem with these abstractions. We use words that imply a lot of things, but the reality is they don't deliver all the things, right? And that's part of the hype. That's part of the hype. And so branding things and naming things, like calling LLMs AI, I think was a huge disservice to the practical uses of LLMs, because now people are demanding things that won't come out of them. So he points out that you really need to have a robot that can try things and experience things.
The humanoids, the things that Tesla's building.
Yeah. So this is why don't bet against Elon Musk. If there's anybody who's going about this the right way to do something, it is Tesla, which is not a car company.
Yeah.
It's a robot company whose first robots happen to be cars that would transport people around.
Yeah.
They are an AI company. They've been an AI company since pretty much day
Elon's
one.
on a different level. You know, everyone's trying to like get all these LLM
Yeah.
experts, all these people from OpenAI. Elon's building the thing that can actually.
Well, and then he knows
touch,
so he's got all this data from all these cars driving
Yeah.
around, the visual stuff, and that is the reason why he insisted on doing a visual only AI and not using LiDAR.
Yeah.
He wanted to be limited by the same constraints as people, because he's not trying to just make the car work better. He's trying to make an experiential AI that
With
can
the
recreate the
robotaxi,
human
yeah.
experience as much as possible.
Wow.
Right? And so that's also the reason why now he's making humanoid robots, because he's coming to the limits of what can be gathered from driving cars around, because he's solved the self-driving car problem.
Yeah.
Right? So now you need something that can try things out, and making an accident won't kill somebody,
Yeah.
which is a problem with the car model, right? It can do things. So that's why the robots for Tesla is like that's the thing. And so now you can train an LLM and you can put in different types of processing, and now we're so like the car thing, that was a bounded non-determinism. Right? The model's bounded because it's only things that cars will encounter on the road, so he was able to simplify the problem. Yeah. He's not trying to solve true intelligence from day one. He's got this subset of it that he's defined. He's restricted the model, so it's bounded, but it's non-deterministic because he's dealing with the real world. He doesn't know when a car or a child or something is going to come into the path, and it needs to be able to deal with that.
So, that's crazy. Now it's just clicking in my brain. Out of everyone in the AI race right now, right?
Yeah.
Now that we've already kind of established, okay, everyone understands LLMs, everyone's doing LLMs, we're going to hit a limit. Now it's like the next thing. And out of everyone within this race right now, Elon has like a front run because he has these machines, these humanoid robots that could actually experience the world like humans do. He had multiple years of experience with cars that could drive the way humans drive, like not using LiDAR, like Waymo and what's the other company? Zoox, like they all use the same like LiDAR. They're just making the thing work, but they're not actually building the knowledge base and understanding in order to build upon.
I mean, they're doing it from the perspective of something that has LiDAR, right? Not from the perspective of a human. So I mean, it's a different constraint of the model, right? So Elon's is closer to the human experience, and theirs is closer to a computer experience.
But obviously, we want to build intelligence, which is the human asset.
That's what they say the goal is.
Yeah. Okay, now I think we want to go to the next, like you said, like what are you excited about? What are you building? And also, I think for a lot of people, because we're putting this on YouTube, LinkedIn, and all that, there's going to be a lot of young professionals or people within the field working. How did they use AI? What can they expect to use AI in their fields?
Yeah, good. So when I say AI, I mean augmented intelligence.
Augmented intelligence.
I mean tools that helps us intelligent humans be able to do things better, right? In a way that is not fully deterministic.
Make humans do things better.
Of course. So when I say artificial intelligence, it's like they can't even define what intelligence is. I call it augmented intelligence because intelligence under that definition is whatever the heck I want to do, which is write a rap song, build a bomb, compute my taxes. These are all, for some definition of intelligence, intelligent things, right? So, I think that's what we're going to see. All technology is a multiplier of ability. Yeah. Right? Technology, if you think of it in economic terms, right? What has technology done? The Industrial Revolution and now the Information Revolution. What they have done is they've just made individual humans so much more productive that now they have free time and stuff, which we didn't have before, right? Your subsistence living. And so, but it was all based off of skills that the humans had. All technology is a multiplier of ability. Yeah. So if I have a $10 million SAP accounting system and my accounting skills are 0, anything times 0 is 0, right? But if I'm a competent accountant and it takes me 20 other accountants to help me run this one company, but a big computer, augmented intelligence accounting system comes in, I as an individual can now do the accounting for 20 companies. Yeah. That's what we're looking at. Okay. So that's what you're looking to do with AI. If you can create a frame of reference where what you're doing is you're taking something that a human does, but you're making them far more productive and capable of it. That's like the level 1 of using AI. That's the first obvious thing. Okay. Now, the next level is going to be, and this is when you start saying, okay, now we're talking about something that resembles reasoning and intelligence, is when an AI system actually helps humans discover something that they wouldn't have discovered on their own, or create new abstractions that are now more productive than the ones that humans came up with. And so that's when you're arguably saying, all right, like all the AI geeks will say, yeah, we've done it. That's the singularity and stuff. No, it's not. Yeah. I mean, we're just using a tool. Like a jet can take us around the world, in a few hours. Yeah. What is but humans had to know how to pilot it and build it and all that kind of stuff, and it didn't replace us. So all right, and I don't want to get too much into the depths of the singularity argument. It just again it over advertises, overclaims what we can do, and underappreciates what it means to be a human and do these things. Now, we haven't seen an AI do any of these things, by the way.
Okay.
Despite these trillions of dollars of investment and the claims that AGI has already happened and all this. Yeah, this is all hype to keep the venture capitalists funding this stuff and to keep their coffers going. The head of AI at Meta, he's got the right perspective. Yeah. Musk has the right perspective. Yeah. Everybody else that I see is, and I don't follow the personalities that much because I'm too busy. I can either be somebody who comments on it and follows it, or I can be a person who does it. Yeah. And I'm first and foremost a tech engineer, and so I am enjoying doing it and getting practical results. Right. Yeah. I am enjoying building a technology that multiplies people's ability. Okay. The first client that we really deployed something that was AI based was a local Thai educational curriculum publisher, and EdTech is something. Both of my parents were academics. My mom was a 7th grade geography teacher. My dad was the assistant superintendent of Fort Smith Public Schools, and I was a very poor student, but a forever learner. I loved learning. I just hated school. I was not the guy who liked being told what to do, being the contrarian again. I had over the years, because I've consulted with helped a lot of startup firms and stuff, because I enjoy doing that. I've been like a fractional CTO, and I still offer those services. Call me. But one of the most depressing areas of technology has been education. Yeah. And even Apple from the beginning days, and Bill Gates are all talking about how technology is going to revolutionize education, and it did not, right? And EdTech companies have burned through billions and billions of dollars that gone to zero, and they all make like 3 classic mistakes. But the main thing they do is they take the teacher out of the equation. They try to replace the teacher, and they also think that it's easy to put together a curriculum that is universal and teaches. So our client, anyway, so I started refusing to do EdTechs because you guys are doomed from the start. Nothing's going to come out of this. But I had this client who years ago I did an IP due diligence effort with. Took them to Miami and Silicon Valley to negotiate this thing, and so I had a good relationship with them. They have like 80% penetration for the Thai school system market, so they already had the clients, and they had 60 years worth of curriculum that they had created. Right, so they had all the hard stuff, and they were in the classrooms, and so what I did was I designed a system that didn't replace the teacher, right? What we said is now, okay, the teacher is the analogy is like working out at a gym, right? So if you've ever gone to a gym and got a personal trainer who's good, you'll find that working with that personal trainer will make you 3 times more effective than doing it by yourself, even if you know what you're supposed to do, even if you're smart enough. And this was definitely the case for me when I was in Atlanta. And so, it's a personal trainer like enhances your efforts and your energies. And what we were trying to do is say, okay, for teachers, the teachers are personal trainers for learning outcomes, right? One of the problems with education in Asia is that it's rote memorization. You get graded on how well you're able to repeat back what the teacher told you. Right? The teacher is the source of universal truth, and that's what you're measuring. And that's not very effective. What we want to do is we want to change the teacher's role to be a trainer for learning outcomes and improve learning outcomes. but this technology augmented the teacher's ability to teach in class. So it brought into her hands on her device the exact content that was relevant for her students. When the students participated in these gamified challenges that we had, the AI is watching how they performed and who performed how and what learning styles they did. And so it was able to recommend the most optimum next content for this particular classroom and even for this particular student's homework assignments, right? Just on the tips of the fingers. But the teacher guided the whole thing, right? So it's all this kind of stuff that the teacher can't keep into her head and track across all the classrooms, but it's at her fingertips and she's able to use it. And so it was, and also it meant that the teacher didn't have to spend an hour every night grading quizzes, which the teachers hated. So it got good adoption. So that was a first use of an LLM-based AI. And also we had to deal with the fact that it was Thai language, which is the hardest language in the universe for computers to parse. We don't have spaces between words.
Hardest for people to learn as well, I think.
Well, I don't know. I'm poor at learning them all. But and so SCB10X has developed an LLM that focuses on Thai language that was pretty effective, but it's super, super expensive to train these LLMs. It's crazy expensive to make an incremental improvement for them. And I think, for example, like when GPT-3 came out and when they had like the 3.5, the rumors that I heard was that like now it's not just one big LLM. It's like at least 3 different models that are working together. Because what I think that at that point in time, they hit the overtraining limit for a single neural network for the size they were able to do. So I think we've already hit, what a single LLM neural network model can absorb and be productive at. So now we've got to combine these other things. So you're talking about, okay, what is AI? The old versions of AI that were something that was effective is image recognition, right? Like for pick and place boards on computers, it's just recognizing in a very restricted domain. It's not recognizing everything. Like, is this component in the right place and at the right spot? So people call that AI. It's a pattern matching system. It's also built for the most part on neural networks and some deterministic computing as well. And so you're getting the next stage of what they're trying to build, you've got these symbolic AIs and you got these multimodal AIs, right? So the multimodal AIs is just basically, instead of just taking text input of the world, I can now understand things like sound, so music and voice, and also images, so videos, pictures and videos. But really all those is that's a layer on top of the LLM.
Okay.
That is using classification systems, which are classic things that we've been doing, I would argue probably since the 70s, but certainly the 80s and 90s. I know I did classification systems before. That will then translate this wave patterns of sound or these visualizations of images and pictures, translate those into some finite set of, again, tokens that then the LLM can process. So there's sort of just like a translation layer to the LLM. So it doesn't change it doesn't change the reasoning ability. It just changes, these are different types of inputs that I can use for my LLM, which is important, right? For, again, solving the human-computer interaction problem. Doesn't address anything about it being more intelligent. It's like, I can see a picture and I can say this person is doing this and all that. It's still limited by what you can do with an LLM. Symbolic AIs is now trying to, using probabilistic methods, discover an ontological relationship, actually, but probabilistically instead of deterministically. And this is kind of interesting because what this does is this now allows you, when it observes concepts, and when people are looking at graphs with the lines between them and stuff, everyone's always looking at the circles or the squares, right? The most important part is actually the lines between them, the relationships, the predicates, right? And so when you have an ontology, and this is what the symbolic things are doing, now when there's a relationship between two objects in this line here, we can attach a function on that line. And that function can be a deterministic function that a programmer writes to process something. So it's like, if I recognize this input and I want to accomplish something that results in this output, here's a function I can call on that input. That's programming. This is what all code, this is what all functions have always done since day one. In the 40s and 50s is literally what's going on here. But they're trying to do it. I assume, I see, and from what I'm seeing, they're all trying to do this with this probabilistic thing. Now the problem is, probabilistic systems accumulate errors, right? So you hear about quantum computers, right? Quantum is all probabilistic systems.
We should make next episode about that, because I feel like a lot of people, they hear this, they don't actually know what it is. I actually don't know what quantum actually is.
Well, the base issue that I wanted to bring up in this case is that, people are hearing that quantum computers are going to, destroy encryption and all that kind of stuff as soon as we get this number of qubits, which are these probabilistic, it's like, oh, okay, we get 10 qubits, it's done. Bitcoin is, trashed and all that kind of stuff. Problem is that as each qubit depends on the previous qubit, they accumulate errors, and so the noise error rate goes up so high that after you get past a couple of qubits, the results are useless and don't do anything to you.
So Bitcoin's still anti-fragile.
Yeah. Although it is like the encoding the encryption they use is one that will eventually be broken, but that's a solvable problem. It's not going to take away Bitcoin. We already know quantum resistant algorithms that we can fit in and back it up. But anyway, so the this inherent issue with pure probabilistic systems that just start accumulating errors are going to result in, as we get more and more complex, going to result in worse and worse hallucinations. Yeah. Right. And so the model that I have been pursuing, because I come from creating domain-specific languages. That's kind of like my personal passion and love to do that, and which really involves creating a domain, creating an ontology for that domain, and then creating a language that represents that. So what we're doing is we're taking customers' content, and we are discovering, not prescribing, right? We are discovering using LLMs and other probabilistic techniques. We are discovering an ontology that represents that content and those tasks. So we're using probabilistic systems to discover a deterministic ontology. And then we're mapping this deterministic ontology back on to their content so that we get a hybrid deterministic probabilistic AI system. And in those cases, for us, the LLM is a commodity, right? The better the LLM is, it takes us 5 minutes to switch out the LLM to a new one, and we're done. Changing the encoding models actually is a little bit more expensive because we have to re-encode all of our data. But the LLM itself, bada bing, bada boom, we're always upgrading the LLMs or trying different LLMs on things. Whereas people who are LLM focused are having to invest all this massive amount of capital and energy and money to do incremental improvements that are only probabilistically going to work and will eventually overtrain and fail. That is the model that is being pursued by these companies that have the $1 trillion valuations or whatever and turning through there. And they don't seem to be understanding they just like, I don't know, maybe it's because it's all young people, right? They don't know what they don't know. Yeah.
So okay, because you're doing this hybrid model, can you give a very easy example to people? For example, right, you're like a business owner or something, because I think these AIs will eventually be everywhere, or like just kind of like tools for companies, businesses, small businesses to use. How would a small business owner use a specialized tool like the one you're talking about, like a hybrid one? Like, just give a quick example.
So we have a very good demo for like my wife has a real estate rental company thing, and she's got this data that she inherited from a previous company that was in a WordPress website. Yeah. Which unfortunately WordPress, their database isn't actually fully relational, so you can't look at the database and see the relation patterns between the data. It's because it's in the code. Yeah. So we would call that a mostly normalized database. But then the other set of data that she has is just some folders on a Windows machine, and each property has a directory name, has a file that says info.txt in it that has the text information about the property, and then supporting documentation and a bunch of images. So it's completely unstructured data, right? This is two different ways of representing the exact same data, which is what's the condo rental market in Thailand. Gluing these things together in the traditional computing way would be, okay, bring in your data analysts, spend 3 to 6 months figuring out some sort of schema, and we can sort of replace the word schema with ontology, how this, what is the business of renting properties and real estate, and how this condo is in this building, which is in this location. What are all these relationships? What does it mean? Who are the stakeholders in here, right? It's going to take you months to build this, and you're going to get like the greatest common factor or least common denominator of both databases, because you're trying to fit everything into a single schema. You're going to miss something that was represented here to catch something that was represented here, because they're going to have different ways of representing the same relationships. And so this is a hard problem, right? And then you got to incorporate all that data into a single database. And now that has to be your source of truth, and you can't be updating these other two things while you're doing that. So what we did is we have a system that, and it's not built. So we have a product called Big Vault, and it's not built for any specific domain. But you can write a domain document, which is just a human describing how the real estate business works. So it's like a couple of pages. Yeah. And you can point to this, both structured and unstructured data. It consumes it, and it discovers the ontology that is represented by all the data in the system. And then we pull that into a single vector style database. We have a combination vector and graph database that now we can ask it queries like a person, and it's a single perspective of the data from both databases.
Oh, so you can like take unstructured or whatever, like PDFs, files, Google Sheets or whatever, and then you put it in, and it can read all of that?
Correct. And so so it allows like the real estate agent to view it as if it was like one single database.
Okay.
For her, and she can ask it questions and stuff. And what was really cool was when my wife first tried it, she put in, I said, because put in, what would you ask if you're, as an agent, put in some things and ask, I want something that's, under 50,000 bought on Tonglo for 2 bedrooms, and boom, all of it, the results it got were, geographically on Tonglo, had 2 or more bedrooms, and were under 50,000 bought.
Okay.
Then she asked for something. Okay, so I want something on a high floor. The word high floor did not occur in any of these databases, but it's a concept of the nomenclature for a real estate agent, high floor or low floor. And so it came up with nothing. It's like, what, doesn't know what a high floor is. So all we had to do, now that normally like on a regular system, it was like, okay, well, we got to do a feature request, and we got to bring in the consultant, and how are we going to alter the database, and how are we going to process all the data. We took the domain text document, and we described a high floor. Say a high floor is when you have a building that's 10 or more stories tall, and it's in the top half of the building. And if you're not a high floor, you're a low floor.
Okay.
That's what we wrote in the domain document. We re-embedded the content, and then so this all happened within the span of like 2 days.
Okay.
And then now she can ask for a high floor.
So yeah, okay.
That's augmented intelligence, right? So we added this concept, this ontological concept of a high floor, which does not exist in the data. It's not present in the data, but it's present in the mind of the user. We were augmenting her intelligence to introduce this through an ontology.
So from what we are talking about today, I think, you saying you augmented intelligence, you kind of like help humans make better decisions, work faster. It's like an extension of our being and our ability. This tool can be applied to a lot of different areas, not just within real estate, right? Like if you have like a factory, or if you have like a small business where you have so much paperwork, because I know that is like a big problem in a lot of these companies. Like there's paperwork from like 10 years ago, everything. They could
these
just
BI systems.
Yeah, could they just scan it and then go in, and then that would work?
So that's actually the market that I'm chasing.
Okay.
Because like when I was a consultant in the States, a lot of what I was doing was cleaning up huge BI system projects or whatever, or they'd invest a lot of money into their BI system, normally like SAP. And so they're putting all these things, they call them data lakes. They're coming up with all kinds of new terms where they put all the company's data in one place. They have this like HENA database, which is an in-memory database. Like, what the hell? It's nuts. But they're charging a lot of money. But then the manager finds, okay, I want to make this new report because I've got this idea that I have about my business. And he finds that he's got to call in his data analysts, and it takes 6 weeks and $6,000 to get this report, even if the data is present, right? The first thing the data analysts have to do is like, is this data even present in our BI system? And then if you got to wait 6 weeks and spend $6,000, and then when you see the first report, the initial answers you get just bring up more questions that you need to iterate over this. So the latency of doing this manually is so expensive and so high that people get very little return on investment for their BI systems. And so what we've got is we've got an event store model that we've built on top of this Erlang technology, so we can distribute it at scale, and we can instrument an existing BI system so that anytime it writes something or changes state, it will also publish that into our system. So you can keep your existing BI system, but now we're also aware of what you have. We do this ontology discovery for your content, and we know where these records are actually sourced at. And now you can ask questions to your LLM and discover what's in your system and play around with it, right? You're still going to be subject to hallucinations and stuff, but you as the domain expert, right, the manager of the company, can figure out if your idea is promising or not and learn about that, so that eventually you want something that is a deterministic report. Now you can call in your analyst and spend the 6 weeks and $6,000 and get the report that's precisely what you need to do the next piece of business that you want. So it's a fantastic discovery tool to augment your business intelligence system. That is the target of what we want Big Vault to be.
Based on off the top of your head, I think just like in a very short way, what are ways different businesses can use this? Oh, you gave the real estate example. Like what else? Like law? Or like what else?
So the legal profession is an area where there's actually been some pretty deep development in actually creating ontologies for legal profession. Now, of course, they're jurisdiction specific, right? The type of law that you are in the U.S. isn't the same type of law there is in Thailand. But yeah, this is an area where we've got a partner with a local law firm that we're going to start incorporating their content.
Yeah.
And then there's also a lot of like, you also need a fine-grained permission model to make sure that only the right people can access the right content, which is something that LLMs cannot do on their own, right? If you put it all onto this LLM, you're screwed. So we segment things out for the way our vector database works.
And who else can use this?
I mean, it's just a multiplier ability, right? Accountants can do this. I did a system for helping drug discovery for a major drug platform. Pharmaceutical company in 2008, where they OCR'd all of their human trials all the way back to the 1970s, and just using an existing ontology for the medical industry, which is a really strong good one. So this is where these things really do, and using a full text search, which is a completely deterministic system, and stemming, we were able to have it recognize that certain amino acids from certain proteins were present in these studies, and this side effect happened to coincidentally occur, that allowed a researcher who understands this stuff to narrow down whether or not, they got to choose between, they got these 4 promising results, which is the most likely to come up with something that's going to have a result that we can commercialize, right? Because it takes $1 billion to take a drug from zero to the market. And so you're looking at hundreds of millions of dollars of investment. And this tool, using no LLMs, was able to vastly help see from all their past data patterns, which a human would not have recognized, just from using stemmings and full text search. Putting that with an ontology with an LLM, I know this is what pharmaceutical companies must be doing. And if you're not and you want to, you can give me a call because I can help you out. But that's a very good area of research where there's been good ontologies that allow you to do formal reasoning. And so what we do, we take this probabilistic system and we bring in the deterministic aspects of it. So now you can write code that allows you to do real reasoning based off of what a domain expert would want, but you can do it at scale and very cheaply. And so what this means is that the smarter your domain experts are, the more valuable your output's going to be, because it's multiplying that ability. It's not going to build it on its own. It's not going to think of it on its own. If that's what you're investing in, or you're a development company who's not hiring programmers because you can think you're doing it all with LLMs, you're in for a major disappointment. Certainly for the next couple of decades. Me personally, for the rest of human history, I think. I don't think it's going to happen, but we can get closer to something that resembles it. That's useful, right? It's a working model.
Nice. I think for today we are coming up to the time. I think that was a really good first episode. Guys, so if you like the conversations that we've had, we are going to be doing this once a week. It will be on LinkedIn and YouTube, the full, and then I'll also cut the clips So,
Good idea.
Ben can share them and then do different questions. But yeah, Ben, if they want to talk to you, if they want to contact you for more information about this system that you've built, how do they contact you? How do they find you?
So my company is called Biggest Lab. Our website is biggestlab.io, and I'm sure by the time this gets published, there'll be a QR code here.
Yeah. And also, we'll be publishing this on both my LinkedIn, his LinkedIn, the Biggest Lab's LinkedIn, and also on our YouTube. That is this name.
All
right. Cool. Thank you. Bye.